What's up? What's up? What's up? What's up? This is gonna be uh balancing, oops, read balancing redox reactions worksheet. I'm not gonna waste your time. Yeah, let's get right into it. Okay, so how do we balance this redox reaction? All right, this is an acidic solution. So, the first step, right, is to break this one up into the oxidizing and reduction thing. It doesn't matter like oh if you identify like which one's oxidizing, which one's like reducing. It just matters that you break them up. And the way you break them up is you notice that, like which ones have like which which two, which two are the same. That makes sense. So like MnO4, that's one of them. BO3, BI, that's the second one because they're similar. Hopefully that's not too hard. But yeah, let's write that out. So it's Mn2 plus, we'll put its arrow and go to MnO4. And I'll write the second one as BiO3 minus going to Bi3 plus. Yeah. Also, this video is going to be quite a long one. There's like 4 questions in here. This took me like an hour. I'm glad I would do this one. So yeah, 2 times speed is your best friend right now. Okay, Mn2 plus to MnO4. So first things first is uh you want to find out the oxidation numbers. So this Mn2 plus, right? This plus 2, since it's an ion, this oxidation number will be plus 2. MnO4, what was it minus here? MnO4 minus, okay. Um, yeah, let's just see this one real quick. So oxygen, you always start out with oxygen. You always assume it's gonna be -2. So in the end, it has to be negative. It has to be the overall reaction has to be negative. So since oxygen is -2, we write -2. And since there's 4 of them, right, we write -2 times 4. And so in order to get -1 at the end, right, because the charge is -1 at the end, it's gonna be -8. So plus -8, -1. X, X is gonna be 7, 7, right? I'm not tripping. So for each atom, right, for each atom, magnesium is gonna be +7, and then for each atom for oxygen is gonna be -2, as we said earlier, because we assume oxygen's always -2. That's it. And okay, once you have that, right, then we add oxygens. You feel me? We add oxygens. Okay, so right now we're not going to be using these oxidation numbers just yet, but it's good to have them right now. And later I'll show you how the oxidation numbers come into play here. You feel me? Wow, I'm saying the most cringiest things. Jeez. Okay. Okay. So there's four oxygens. The way we can balance this out is by adding 4 water molecules on this side, on the reactant side. So it's gonna be Mn2 plus 4H2O, right? Going to MnO4 minus, right? So all we did was just add the 4 water molecules. And this is because there's 4 water molecules. There's 4 oxygen molecules here, and there's 4 oxygen molecules there, right? And so as you see, there's an imbalance right now because look, there's 8 hydrogens. And so in order to balance 8 hydrogens on one side, you need to add 8 hydrogens on the other side. So Mn2 plus goes into 4H2O. goes into MnO4 minus, and then it's going to be 8 hydrogens to balance out. Right, and hydrogens are always plus. That's just because it's in the group one. Um, H2O is a neutral because it's water. Water is like neutral. Yeah, okay. So with that, right now, since that's the first step, right? Or the second step, or whatever step. Well, the first thing to do is to balance the oxygens. Second step is to balance the charges. All right. So, on this side, the reactant side, we have a grand total of a positive 2 because there's one positive 2 right here and none right there. So it's gonna be positive 2. Over here, right? It's gonna be -1 plus 8, or 8, right? There's 8 of them, and then each hydrogen is +1. So 8 minus 1 is gonna be 7. All right, so there's an imbalance in charges, as you see here, because one side has 7, one side has 2. Okay. And so I don't know actually know why I found the oxidation numbers in the beginning. Okay, well, whatever. Extra practice. Okay, so as you see here, the reactant side, the charge is +2, and the product side, the charge is +7. And so in order to balance the charges, we need to add 5 electrons to the product side because adding electrons is negative. Electrons are negative. So 7 is going to be brought down to 2. So it's going to be Mn2 plus 4 H2O. That's going to be MnO4 minus plus 8 hydrogens with the plus sign. And as we said earlier, adding 5 electrons. And electrons are negatively charged. That's why we add a negative sign here. So here the charges are balanced. And yeah, so that's it for the magnesium. And now all we have to do is the same thing, but to the Bi, whatever Bi stands for. Okay, so yeah. In this case, we see that there's 3 hydrogens on one side. Oops. There is 3 oxygens, I mean, 3 oxygens on one side. So to balance 3 oxygens on the reactant side, we have to add 3 water molecules from our product side. So this is going to be BiO3 minus, going to be Bi3 plus, and adding 3 water molecules from the product side, right? Because there's 3 oxygens here, and now there's 3 oxygens here. Sweet. All right, now look, there's 6 hydrogens here. There's no hydrogen on the reactant side, so we need to add 6 hydrogens to the reactant side. BiO3 minus plus 6 hydrogens plus Bi3 plus 3 H2O. Okay. Once that's done, now we need to balance charges, right? Because the first step was to balance the oxygens and the hydrogens for acidic solutions. Second step is to balance the charges, right? So on this side, reaction side, we're gonna have a grand total of a +5, right? Because it's gonna be -1 here, and then -1 plus 6, right? Because it's 6. That side is gonna be +5. This side is gonna be +3. And so it's an imbalance on electrons are in charge. So we need to add 2 electrons on this side. 2 electrons on this side, so BiO3 minus plus 6H plus 2 electrons on this side. That's going to go to Bi3 plus 3H2O. All right, and so we're almost done here. What we need to do is to find the least common multiple of the electrons on both equations. So on this side, we have 5 electrons here. And then on this side, we have 2 electrons here. And so the least common multiple of 5 and 2 is 10. So we need to multiply both sides in order so that the electrons are 10. So we can combine them. Sweet. So in order to get to 10 from 5, we need to multiply everything by 2. It's gonna be 2 Mn2 plus 4 plus 8 H2O. It's gonna go to 2 MnO4 minus. You know, 16 H plus because 8 times 2 is 16, and 5 times 2 is 10. 10 electrons. All right, same thing for the side. But however, you have 2, and what times 2 gets to 10? It's 5. All right, so we need to multiply everything by 5. It's gonna be 5 BiO3 minus plus 30 hydrogens plus 10 electrons. It's gonna give us to 5 Bi3 plus 15 H2Os. So now both the electrons are matching, and this will now we can combine both equations. So just combine them. You feel me? Please stop saying that. Okay. We just need to combine them. All right, so 2 Mn2 plus 8 H2O. Right, we're just bringing this side down. All right, now I need to bring this side and plug that bad boy in here. Plus 5 BiO3 minus plus 30 H plus 10 electrons. Go give us oh right. Now we just add this side over here. So it's gonna be 2 MnO4 minus plus 16 H plus 10 electrons. And then we add this in here. 5 Bi3 plus 15 H2O. Sweet. Now the fun part, I like to call it, this is kind of bad. Just starting to think that chemistry is fun now. It's like I'm going insane. All right, anyways, yeah, so now we can cancel the electrons out. So there's 10 electrons on the reactant side, 10 electrons on the product side. Cancel those bad boys out. H2Os, right? There's 15 on this, 8 on this side. There's 15 on this side. So 15 minus 8 is gonna be 7. 7 H2O. Yeah, and then now let's just rewrite everything. So 2 Mn2 plus 5 BiO3 minus plus, oh, right, the hydrogens. So on one side we have 16 hydrogens, on the other side we have 30 hydrogens. 30 minus 16 is going to be 14. So it's going to be plus 14 hydrogens. And then now moving on to the product side, 2 MnO4 minus plus 6. Oh wait, this 16 got canceled out. Plus 5 Bi3 plus 7 H2O. And this will be your final answer. All right, we are. Okay, let's keep it running. You feel me? Let's keep it running. All right. Sweet. All right. Next problem. This should be a little bit easier. Okay. So let's get on with it. So first, what we should do first is we should break up the redox reaction. So once that's going to be P. Oops. P goes into H2, EO4 minus. The other side is going to be, on the other side, it is going to be Cu2 plus going into Cu, right? Um, so, and then we see that, let's just focus on this side real quick. There is 4 oxygens on this side. So we need to add 4 water molecules. So P plus 4H2O gives H2PO4 minus, right? Okay, and then looky here. Okay, now we need to balance out the hydrogens. On this side we have 8, and then this side we have 2. So how many do we add on to the product side? 6. Exactly, 6. So it's gonna be, we're gonna just rewrite this. So PH2O H2PO4 minus plus 6 hydrogens. All right, so now that we've balanced the H's and the O's, second step, all right, is to balance the charges. So phosphorus by itself, since it is in its pure uncombined state, you have an oxidation number of 0, 0. H2O is by itself, it's just a 0, it's neutral. This side, give me -1 plus 6, which is gonna be 5. Right, there's 6 hydrogens on this side, and then -1 charge on this side. Sweet. And then so if this side has a charge of +5 and this side has plus a charge of 0, how many electrons do you guys think are we gonna add to the product side or the reactant side? So the answer is we're gonna be adding 5 electrons to the product side. Okay, so we're gonna rewrite this to P plus 4H2O, H2PO4 minus, plus 6H plus. It's gonna give us, and we're writing 5 electrons. All right, cool. Now you have that. Let's move on to the copper, I think. Cu, probably copper. I don't know. All right, so copper, as we see, there's no oxygens. In fact, there's no hydrogens. So you might be thinking, what do we do, Mark? So we can actually skip that step entirely, and we can just balance the charges. So on this side, we have a charge of +2. On this side, we have a charge of 0, because Cu is its free uncombined state, right? And so we need to be adding 2 electrons to the reactant side. 2 plus 2 electrons, and then rewriting that down. All right, cool. Now we need to find the least common multiple of the electrons. So on this side, we have 5. Over here, we have 2. Likewise, in the first problem, the least common multiple is going to be 10. So we need to multiply this by 2, multiply all of this by 5. All right, so let's do that right now. Over here, it's going to be 2 phosphorus plus 8 H2O, 2 H2PO4 minus, plus 12 H plus 10 electrons. Right, I think I did that right. Yeah. Multiply this by 5 Cu, 2 plus 10 electrons, 5 Cu. Sweet. Now we can just combine them. Okay, so it's going to be 2P plus 8 H2O can give us 2 H2PO4 minus plus 12 H. Oh shoot. Well, sorry, went too fast. We need to add this reactant side. Plus 5 Cu, 2 plus 10 electrons. Now onto the product side. 2 H2, from minus, plus 12 H plus 10 electron. Product side right here. plus 5Cu. Okay. Now we just cancel out things out. 10 electrons, 10 electrons, bada bing, bada boom. Uh, yeah, I did. 8H. Oh, actually, yeah, that's it. Because the H2, there's no other H2Os, there's no other hydrogens. So let's just rewrite the new and final answer. 2P plus 8H2O plus 5Cu2 plus going to give us 2H2PO4 minus plus 12H plus 5Cu. This, my friends, will be your final answer. And just when you think, all right, take care, guys. That's the end of the video. Later. Peace. Psych, you thought wrong. There's actually a second page to this full worksheet. Fooled. You guys did not see that coming at all whatsoever. The first page we did acidic solutions. This one we're going to be doing basic solutions. Little different, just a slight difference. When we balance the hydrogens, we're going to be adding hydroxides. Because we need to balance out the acidicity or something. But I don't know why, but exactly. I can't really tell you on top of my head, but just know that for basic solutions, you need to be adding hydroxides. So I'll show you right now. Let's get on with it. Oh, sweet. All right. So first things first is to separate the zincs and the nitrogens. So one's going to be Zn. Going to go into ZnOH4 2 minus. On this side, it's going to be NO3 minus. I'm going to go to NH3. So the first thing is first. Well, actually, let's do this one first because I can explain basic solutions from this one better. So, as you see, there is 3 oxygens on this side, 0 oxygens on the product side. So we need to add like so, like like acidic solutions. We're just adding the 3 water molecules, 3NO3 minus to NH3 plus 3H2O. Right? And then since we need to add the hydrogens, right? There's 3 plus 6 is 9. And there's 0 on this side, so we need to add 9 hydrogens. So it's gonna be NO3 minus plus 9 hydrogens. We go to NH3 plus NH3 plus 3H2O. And so, right, as I was saying before, when you add the hydrogens, you also have to add hydroxides. So NO3, so since there's 9 hydrogens, we need to be adding 9 hydroxides. So NO3 minus plus 9H plus, gonna go NH3 plus 3H2O plus 9OH minus. Okay, don't forget the minus. Okay. And then when you have oh wait, sorry. Spoke wrong. When you add the hydroxides, you have to add in equal amounts to both sides so that it'll be equal, so you don't have to keep on balancing it. And so whatever you do to one side, to the other side. The reason why you don't do that for hydrogen is because Before adding hydrogen, it was unbalanced. Now you balance it by adding hydrogen. So this whole thing is balanced. It's fine, completely fine. But when you add hydroxides, it's added both sides. NO3 minus plus 9 hydrogens plus 9 OH minus. So we do one side, we do the other side. NH3 plus 3H2O plus 9 OH minus. So what we see here is that this H can combine with the OH, so we give you H2O, NO3 minus plus 9 H2O. This is going to give us NH3 plus 3H2O plus 9 OH minus. Sweet. All right. Well, something's burning. Okay. I'll be right back. All right, never mind, guys. That was actually my food. Or not my dad. My dad was making me food. So, but it's fine. Just a little crispy. You feel me? All right. So, as I was saying, we just combined the hydrogen and the hydroxides, and now with all that, we have to balance the hydrogen and hydroxides for basic solutions. Second step is to balance the charges. On this side, we have a total charge of -1. On this side, we have a total charge of, well, 9 OH minus is going to be -9. Oops. So -9. Yeah, and everything else, I guess, is balanced. So so in order to balance the charges from one side is -1 and one side is -9, we have to add 8 electrons to the side. Well, like my brain's like having a brain fart right now. So NO3 minus plus 9H2O plus 8 electrons on this side. Okay, why is that? What happen here? Why did that turn to 6? Oh, word, yeah. Okay, that's gonna go into NH3 plus 3H2O to 9 OH minus, right? So we see here is that we can actually cancel out some of the H2Os right now. So 9 and 3 can actually turn into 6 and 0. So NO3 minus, actually, no, I'm just like, I'm too lazy. 6H2O. Let's send this one over here. Sweet. Okay, yeah. Now let's balance. Oh, now to this side. All right, to this side. The reason why I wanted to start with the second equation, not the first one, was because this one, as you can see here, there's already hydroxides. So we can just add hydroxides to the other side. So there's 4 hydroxides here. We can just add 4 hydroxides to the other side. Zn plus 4 hydroxides. Zn OH minus. Okay. Now let's balance the charges. This is going to be 4, -4. This is going to be -2. So to balance this, we're going to have to be adding 2 electrons to the product side, because -2 and then -2 minus 2, right? Because 2 electrons is minus, that turns into -4. So Zn plus 4 OH minus Zn OH 4 2 minus plus 2 electrons. Okay, now let's just find the least common multiple. So on this side, we have 2 electrons here. On this side, we have 8 electrons on this side. The least common multiple of 8 and 2 is 8. So we need to multiply this side by 4. 4 is Zn plus 16 hydroxides Give us the 4ZnOH4, 2 minus, plus 8 electrons. Oh, shoot. Okay, now let's just combine them. Oopsies. Okay. So it's gonna be 4Zn. Bring this side down. It's gonna be 4Zn plus 16 OH minus plus writing this side now. NO3 minus plus 6H2O plus 8 electrons. Give us 2. Add in this. I'm running out of room. Yeah, and OH 4, 2 minus. Plus 8 electrons plus NH3. All right, now writing this side plus 9 OH minus. Right, and so now we can just cancel things out, just like slash them. So here we have 9, 16. 16 minus 9 is going to be 7. And then the 8 electrons here, bam, bam, that's going to be down. So the final answer is going to be 4Zn plus 7 hydroxides plus NO3 minus plus 6H2O. Going to give us 4Zn OH4 2 minus plus NH3. And yeah, that's it. Bam. Last one. Woo. All right, so break this up. You know the drill already. It's gonna be OH to H2. Okay, to the side first. 2 oxygens on one side. We need to add two water molecules, so Al plus 2 H2Os to AlO2 minus. I want to go a little faster here because hopefully you guys know what to do. Since there's 4 hydrogens right here, we need to add 4 hydrogens to this side. And since it's in the basic solution, we need to be adding equal amounts of hydroxides. So plus 4 OH minus. Oops. No, I'm just rewrite this because no, actually I'm not. All right, oops. Adding hydroxides to both sides in equal amounts. Plus 4OH. Plus 4OH minus. Now we need to balance charges. So this side's going to be -4 because from the hydroxide, -4 right here. This is going to be oh right, forgot. Because there's 4 oops. Because of the side, we can combine the H2Os. So it's gonna be AlO2 minus plus 4 H2Os. Okay. Plus 2 H2O. Sweet. Okay, so this side the charge is gonna be -4. On this side, the charges are gonna be -1. So to balance the charges, we need to be adding 3 electrons to this side. 4OH minus plus 8L plus 2H2O. Going to be AlO2 minus plus 4H2O plus 3 electrons. Right. And so from here we can cancel out these H2Os. So 4 minus 2 is going to be 2 H2O So 4OH minus plus Al give us AlO2 minus plus 2 H2Os plus 3 electrons, like so. Now, let's do the other side. Okay, yeah, was good. Okay, and so from OH to H2, we notice is that there haven't been any examples in here, but we need to balance the mass. There's one H, oops, there's one hydrogen on this side, two hydrogens on this side, so we need to add two OH. Okay, so let's start. There's two oxygens here, zero oxygens here, so we need to add two water molecules. OH minus to H2 to 2H2O. Okay. And then now we need to add hydrogens. So this side has reaction side has four. This side has four as well. Oh wait, no, this side has six. I can't even count. So this side we need to be adding. Oh wait, what? Well, I'm literally tripping right now. This side has two. This side has six. Four plus two is six. So on the reaction side, we need to be adding four hydrogens. So two OH minus plus four hydrogens can give us H2 plus two H2O. Okay, and then now we need to be adding hydroxides. So four OH, right? Because we added four hydrogens, so we need to be adding four hydroxides. And whatever you do to one side, you must do the other side. Okay, and then from here, we can combine the water molecules, so two OH minus plus four H2O. That's gonna give us H2 plus two H2O plus four OH minus. Okay, and then now we have to balance charges. Charges, this is gonna be -2. This is gonna be -4, right? Because four OH minus. So to balance this, we need to be adding two electrons to the reactant side. Let's add that right now. Okay, now let's find the least common multiple between the two equations. So this side has three, this has two. Least common multiple of three and two is six. Six. So we need to multiply this side by two. Multiply this side by three. So it's gonna be 8 OH minus plus 2 AL, 2 AlO2 minus plus 4 H2O plus 6 electrons. This is gonna be 6 OH minus plus 12 H2O plus 6 electrons, 3 H2 plus 6 H2O plus 12 OH minus. Yeah. So from here we can see that we can cancel some things out. This 6 OH can cancel out with from this 12. 12 minus 6 is 6. This so it's gonna be word word. Oh shoot. This should be H2O. This 12 can cancel out the 6. It's gonna be 6 H2O plus 6 electrons. Gonna be 3 H2. Right. And then now we can just combine both equations. 8 OH minus plus 2 AL plus 6 H2O plus 6 electrons plus 2. Actually from here, we don't have to add the 6 electrons because in the end we're going to be canceling them out. So going to be 2 ALO2 minus plus 4 H2O plus this side 3 H2 plus 6 OH minus. And so from here we can actually cancel some things out. This 6 OH can cancel out. This 8 minus 2 is 8 minus 6 is 2, so it's gonna be 2 OH minus plus this 6 H2O can cancel out with this 4 H2O, which is gonna give us 2 H2O. Bring this Al down to Al. And this is gonna be 2 ALO2 minus plus 3 H2. Sweet. All right. Yeah, this is it. We're done. Give yourself some hand. Happy studying chemistries, chemists. Yeah, let me know if you have any questions. Later.